Circuit analysis, electrical circuit analysis, B and B Tech students. In this video, we see dot rule, coupled circuit, single chain circuit, self and mutual inductance. Apply parallel circuit, coupled circuit, dot rule in 3 cases. In this video, we see circuit analysis subject. Parallel circuit 3 cases. Man Engineering welcomes you. Link at Man Engineering. The dot convention A is coupled circuit simplifies determining the polarity of mutual induced voltage by placing dots on coils. If currents enter the dotted terminals of both coils or both leave, the mutual induced voltage has the same sign. The self-induced voltage positive polarity. If one enters and one leaves, it is negative. The self-induced voltage positive polarity. If one enters and one leaves, it is negative. Single-tuned circuits. A single-tuned circuit is a resonator comprising one inductor L and one capacitor C arranged in series or parallel to select a specific frequency. F4 is 1 divided by 2 pi root of LC, commonly used in radio frequency. RF, that is radio frequency amplifiers to amplify desired signals while rejecting others. It functions at resonance where inductive and capacitive reactance cancel. What is single-tuned circuit? An amplifier circuit with a single-tuned section being at the collector of the amplifier circuit is called a single-tuned amplifier circuit. An amplifier circuit with a single-tuned section being at the collector of the amplifier circuit is called the single-tuned amplifier circuit. Case 1, parallel circuit, coupled circuits. Dot as shown in figure. Entry point dotted is given. I1 of t and I2 of t is current. V1 of t and V2 of t voltage. Apply KVL. V1 of t is equal to L1 di t divided by dt plus m di2 t divided by dt. Apply KVL. V1 of t is L1 di1 t divided by dt plus m di2 t divided by dt. That is, B is same, I is different. Case 1, V2 of t is L2 di2 of t divided by dt plus m di1 of t divided by dt. That is M12 or M21. Mutual inductance between 1 and 2 coil. Current I1 of t and I2 of t enter the coils through the dot terminal. Dot terminal thinks the mutual inductance supports the self-inductance. Case 2, parallel circuit shown in figure. The dotted area is one coil in entry point, another coil is in leaving point. Shown in page. V1 of t and V2 of is voltage. I1 of t, I2 of is current. V1 and V2 formula is obtained. Minus of mutual inductance. Current I1 of t and I2 of t enter the coils through the dot terminal and leave the coil through the dot terminal respectively. Thus, mutual inductance opposes the self-inductance. So, put minus sign for minus m d I1 of t and minus m d I2 of t in voltage equations. Apply KVL. V1 of t is L1 di1 of t divided by dt minus M12 di2 of divided by dt. V2 of t is L2 di2 of t divided by dt plus minus m21 di1 of t divided by dt. Minus sign is important in that case. One dotted point is in coil entry point. One dot point is another coil in leaving point. So minus sign put between mutual inductance, that is opposite the self-inductance. Case 3. One first coil dotted points in leaving point. Second coil dotted point in entry point. Mutual inductance opposite the self-inductance. So put minus sign for minus m di2 of y divided by dt. V1 of t is L1 di1 of t divided by dt minus m12 di2 of t divided by dt. V2 of t is L2 di2 t divided by dt minus m di1 of t divided by dt. Current I1 of t and I2 of t leave the coils through the dot terminal and enters the coil through the dot terminal respectively. Inductance is opposite the self-inductance, so put minus sign. Self-inductance is the property of a single coil to induce an opposing electromotive force EMF within itself due to a change in its own current. Mutual inductance is the production of an induced EMF in one coil due to change in current in a nearly coil. Both are measured in Henry and represent the efficiency of electromagnetic coupling. Self-inductance, the phenomenon where a change in current I through a circuit induces a magnetic flux phi that opposes the change, producing a self-induced EMF. Self-inductance involves only one coil. It is the ratio of magnetic flux linked to the current flowing through the same circuit. Formula is L is N phi divided by I. L is N phi divided by I, where L is self-inductance in Henry, N is number of turns, phi is magnetic flux, I is current. Mutual inductance, the process where a change in current in one coil induces an EMF in a neighboring coil. Involves two coils, primary and secondary. The magnetic field generated by the primary coil passes to the secondary coil. Formula of mutual inductance. M is N2 phi 21 divided by I1. Parallel circuits, coupled circuit analysis. Formula is derived from previous explanation stage. V is same, I is different. Circuit shown in figure. Voltage V, I is current different. I1 and I1 that is splitting into. That is parallel circuits. Number one coil and number two in parallel. Dotted areas in entry point. Two dotted points are in coils in two entry points shown in circuit. L1 and L2 mutual inductance, self-inductance. L1 for first coil, self-inductance. L2 for second coil, self-inductance. V is derived from equations. V1 of t is L1 di1 divided by dt plus M12 di2 divided by dt. V is L2 di2 divided by dt plus M21 di1 divided by dt. Plus sign M12 plus M21 for self-inductance, that is supports the mutual inductance. So put plus sign. that is shown in the coupled circuits, different parallel circuits V1 and V2 voltages, I1 and I2 currents, dotted areas in entry points. In this circuit, mutual inductance opposes the self-inductance. So put minus sign in minus M12 and minus M12 di2 divided by dt d1 by dt in V1 V2 formula. Current flow through the load I1 I2. Minus sign for mutual inductance opposes the self-inductance. So put minus sign. And engineering, thank you.